ceremony on the main stage. それでは早速カンファレンス講演に移らせていただきます。まず最初のスピーカーはイーサリアム創始者ビタリック・ブテリンさんです。We will now move on to the conference presentations. We are honored to welcome the founder of Ethereum, Mr. Vitalik Buterin. Mr. Buterin, the floor is yours.
Okay. Testing. Okay, so today I thought I would start us off by just talking at a high level about some of the things that are happening in the next 5 years of Ethereum's core technology, right? So this includes both the Ethereum layer 1, which is the base on top of which everything else is built. It also includes some really interesting and some really important application layer pieces, some pieces that are closer to the user, and also talk about like what each of these things mean to applications on Ethereum and adds to users on Ethereum. So a big short-term focus that we've had this year is scaling, right? And this includes scaling on the L1, this includes scaling L2s by increasing the number of blobs. And so this year, we already saw the Ethereum gas limit go up from 30 million to 45 million. And there's already research happening to verify that it's safe to continue to increase it even further. We've already seen EIP 4444 start to launch, which means that a large portion of Ethereum history, Ethereum's nodes no longer have to store. And this basically means that Ethereum nodes can continue to be smaller and continue to fit on smaller and more different types of hardware at the same time as the Ethereum blockchain continues to scale. We also saw in the Pectra hard fork the number of blobs go up from the target go up from 3 to 6. And we've already seen L2s increase their scale and mostly start to make use of that extra space. And a lot more things that are coming on the horizon, right? So for around the end of this year, we have planned the Fusaka hard fork, and the Fusaka hard fork has this technology called PeerDAS, which basically allows for a much larger number of blobs, which basically means that layer 2s on top of Ethereum, so including Optimism, Arbitrum, Base, Tycho, Scroll, all of those, will be able to include, again, a significantly larger amount of data. And the plan is to continue to increase this amount of data so that if you launch an L2 on Ethereum, then you know that the space available will continue to increase, and you will be able to publish all of the data that you need, even as you grow and as you get a larger number of users. So this is on L2. I think some of the other exciting things that are happening are the things that are happening on L1, right? And here, the challenging goal is basically that we want to increase the L1 gas limit. So increase the number of transactions that we want to store on L1 while at the same time preserving the protocol's decentralization, right? And this is difficult, right? Because if you just crank up the gas limit, then running an Ethereum node becomes harder, right? And the harder running an Ethereum node gets, the more centralized the network gets. And so some of the tools that we have, some really fascinating technical work that's happening this year. One of them is this concept of block level access lists, where basically what this is as part of every block, the block will contain an object that says these are the things that happened in that block. And the goal of this is basically that one, it enables parallel processing, right? Basically, if the block contains the information that says what are the things that happened as a result of every transaction, then every node that verifies the block is able to process every single transaction in parallel, right? And so Ethereum basically gets as much parallelizability as basically even a chain that is perfectly designed to be as parallel as possible. But at the same time, this is true despite the serial properties of the EVM. So much more parallelizability, and also a lot more parallelizability between execution and between accessing the disk. And also, it works really well with this other tool, ZK EVMs, right? So ZK EVMs, this is a technology that I think we've been talking about, thinking about, working on for basically the past like 10 years, right? So how many people here have been in Ethereum for more than 5 years? More than 10 years? Okay, a couple of people. So if you've been here for more than 5 years, you probably remember me talking about Zcash and ARCs more than 5 years ago, right? So it's this really magic cryptographic technology that basically just happens to solve the privacy and scalability problems that blockchains are not good at, right? Blockchains, they're great because they give you openness, they give you censorship resistance, they give you decentralization, but everyone gets to see every transaction, and everyone has to download and verify every transaction. Because of the first, you don't have privacy. Because of the second, you don't have scalability. Zcash and ARCs happen to solve both problems, right? They allow you to make a proof, a cryptographic proof, that you made some computation and that computation has some particular result. And that proof can be verified by anyone very quickly. And when they verify the proof, they know that the computation was run correctly, even without having to do any more computation themselves. And also, they know that the result of the computation without even needing to see the information that went in. And so you can use it for privacy, and I'll talk about how we're doing that. And you can use it for scalability. Now, for scalability, basically the idea is you have one proof that basically verifies that this block level access list, this object that says, in this block, these are the storage slots that changed, these are the new accounts that got created, this is the amount of ETH that moved from this account to this other account. The proof says that this whole list is correct, that this whole list actually is the result of processing all of the transactions. Right? Now this is cool, right? Because what it means is that you can run a full node, you can run a node locally on your machine that keeps up to date with the Ethereum chain, that processes every Ethereum block, and it can do this without actually needing to do all of the EVM computation by itself. Now, this is also powerful because it gives you a lot of options for really cutting down the resource requirement for running this type of node, right? So today, an Ethereum node, including the history, it takes something like 1.5 terabytes, right? Now, I see people here with laptops. Whose laptop here has more than 1.5 terabytes? Actually, no, one hand's raised, okay. Anyone else, even if your laptop's not here, if you have more than 1.5 terabytes, right? See, basically no one has more than 1.5 terabytes. Now, with EIP 4444, you can basically throw away the history, right? If you throw, and then especially once we take it a couple of steps further, right? And so if you throw away most of the history, it goes down to maybe 500 gigabytes. Whose laptop here has at least 500 gigabytes? Okay. Whose phone here has at least 500 gigabytes? Those exist, right? Now, if we do these block level access lists and ZK AVMs, then you actually go even further, right? Because your node, it will not even have to store the tree. It only has to store the state. Just like the table that says this account has this number of ETH, this account has this number of ETH, this account has this much code, this account has this storage slot has this number. The state today is about 80 gigabytes. Now, let's say naively, we increase the gas limit from 30 million to, let's say, 100 million, right? Increase it by a factor of 3.3. Now, obviously, it'll take time for the state to grow, but like approximate, 80 gigabytes multiply by about 3.3, right? And you get to about 260 gigabytes. Now, whose laptop here has at least 260 gigabytes? Whose phone has at least that amount? See, you will literally, with these technologies, especially I think with the next generation of phones, in many cases, literally be able to run a full node on a phone, right? Because all of this stuff, it will reduce the disk requirements, and then the fact that you have a zero-knowledge proof means that you don't have to run EVM yourself, and so it doesn't matter if your phone has like much less processing power. That's like, okay, all you're doing is you're just like updating numbers in a table, right? And so like literally a full node on a phone actually becomes possible, right? Which is like super cool. And now, why do you care about having a full node on a phone? Actually, I'll talk about that in about 3 more slides. Now, so ZK EVMs, basically, and then you have other tools. So we have gas repricing, you have slot optimization, a lot of different things. And basically, we'll be able to have much higher gas limits at the same time as the Ethereum blockchain becoming much more decentralized, right? At the same time as the Ethereum blockchain becoming much easier for you to run a node and much easier for you to verify the chain and see everything that's happening. So this is really powerful. One other short medium-term focus, interoperability. So who here has coins on more than one L2? Okay, lots of people, that's good. So who here remembers like the process of moving coins from one L2 to another L2? Who here thinks it's easy? Okay, not many hands raised, right? So I argue it can be easy and it can be trustless, right? And there's a number of protocols that are working on this. So there is ERC7683. Also, there's starting like EIL is like another one that a team at the EF is working on. There's starting to be more and more work on enabling both trustless cross-layer 2 asset transfers with a very high standard of user experience. The goal is that ascend from Optimism to Arbitrum should feel equivalent to ascend from Optimism to Optimism or from Ethereum L1 to Ethereum L1. And basically, with at least liquidity providers with reasonably small amounts of money, like you'll be able to make a transfer very cheaply within 2 seconds. So this is step 1. Step 2 is fast settlement for L2s, right? So today, if you're on an L2 and you have ETH on Optimism and you want to take it out and like use the native withdrawing process, you have to wait a week, right? Waiting a week is annoying. So what you can do today is you can basically, like you can withdraw through something like a cross, and what that means is you're paying a liquidity provider to wait a week for you. Paying someone else to wait a week for you is expensive. And so what we want to do is we want to reduce these withdrawal windows from 7 days to 1 hour and then to 12 seconds. Now, how do we do this? Basically, we have to move away from optimistic rollups and we have to move toward ZK rollups. We have to move toward ZK proofs for everything, right? And so, like ZK really is the magic bullet that makes everything work, which like almost in the same I think roughly to the same extent that like LLMs have been this decade, right? Like you remember, like 10 years ago, like you had to go to Google Translate to like translate some stuff, and then you had to go somewhere else if you wanted to draw an image, and then if you wanted to go somewhere like to Google if you wanted to search, and now like you can use an LLM to do everything, right? Like ZK, I think, is like basically that, but for the crypto world. So powerful technology, we need to use it. We are using it. Longer term, also stage 2, so improving trustlessness. Also proof aggregation, so allowing basically zero-knowledge proofs that go on-chain to all be combined together into one proof, and so that saves gas. And L1 load, allowing L2s to read L1 directly. Right, so what we can do is we can get to a world where if you have a coin in Optimism, you can natively move that coin down to Ethereum within like basically 12 or 24 seconds. So this is, obviously an ambitious roadmap, but there's a lot of work that's been happening, and I'm pretty confident that we can get there. So now let's talk about privacy, right? So privacy has been probably the big new topic for Ethereum this year. I mean, privacy is something that I've been talking about basically from the beginning, right? But and then I've been supportive, of Tornado Cash and then Railgun and also ZK identity protocols and ZK voting protocols and all of these things from the beginning. But we have really increased the amount of emphasis that we put on privacy as a base level feature that any Ethereum user should be able to have and expect this year, right? And to me, the reason why is, one, privacy just is important, right? If you remember all the way back to projects that were doing cryptocurrency type things before Bitcoin, if you look at Chaumian eCash from 1982, for example, it actually did not have any decentralization. It relied on a server, but it did have privacy. And so privacy was like the whole time considered this very important first-class goal, right? And I think this is true not just for crypto people. This is true even for a lot of people in the mainstream, like business, even governments, right? Like when we talk about not trusting centralized services, a lot of the time, the type of abuse that you're worried about is not like those services going in and editing your spreadsheet. The abuse you're worried about is how much data that they're slurping up and potentially selling to someone else, and you have no idea what's happening to it without anyone knowing, right? And so privacy is a very important type of security. And it's a type of security that before, we did not have the technology to provide. The early versions of decentralization like Bitcoin, they provided decentralization at the expense of privacy. But today, with ZK Snarks, we do have the technology to provide it. And over the last 5 years, what we saw is we saw privacy go from something where we have some really cool demos and some interesting theory and some fun blog posts, and like you have fun little math equations, and there are some diagrams that I would try to draw, and you can go and like try to learn them, to something that you can go and actually use, right? So who here has sent a ZK transfer on Ethereum already? Okay, good, so I hope that within 1 year's time, there will be 3 times more hands raised. Who here has done a ZK vote before? Fewer hands. I hope that within 1 year, there will be 9 times more people raising their hands on this. Who here has done any kind of ZK DeFi operation before? So not a payment, not voting, but other DeFi. Okay, well, my hand is not raised, but I hope that within 1 year, there will be 27 times more hands, including mine raised. So we can basically go through the list of things that people want to do on Ethereum, and we can give privacy-preserving options for each one of them, right? So on the left here, we have, this is Railgun, this is a privacy protocol, and I mean, it's a really cool privacy protocol. It actually works. A lot of people use it. They also have this association set mechanism that ensures that they can provide strong privacy without backdoors to their users, but at the same time, like ensure that very few bad actors are using the protocol. And on the right, we have Aragon, and Aragon is a DAO project. Like it's a project that's writing software and tooling for DAOs that has existed for a long time. And they have been recently getting into ZK voting. So a lot of progress on these two things. But I don't think we should have privacy wallets. I think we should have wallets, and wallets should have support for privacy features. You should not have to open a separate application to do a private send. The default type of send should be a private send. And these are the kinds of things that we're already starting to work on and do. So some key technologies, so ZK Snarks, obviously. Another one is client-side ZK EVM. So you should be able to prove things about transactions that you can make, prove things about things that are happening on the Ethereum blockchain, prove things about EVM computation locally on your machine, right? And the reason is that we want the privacy Ethereum world and the rest of the Ethereum world to speak the same language. Now, doing this is obviously harder, right? Proving EVM is harder than proving a Merkle branch. But there's a lot of things that can be done to actually make it happen. Privacy pools and association sets. I mentioned this, basically technology that lets you essentially preserve your privacy, but at the same time prove that you're not from some set of known bad actors. Macy, technology for ZK voting, and the trust assumptions in Macy can be improved quite a lot with things like FHE, obfuscation. and sending transactions through mixed nets, right? So when you send a transaction, like it should not be immediately visible, like the link between you and what transaction you sent to whatever like internet endpoint you use to connect to the internet. So basically, we want to look at the full stack, right? And we want to really shift the focus from building cool tech to let's make the average Ethereum user experience private. Now, that was privacy of rights. Now, we can also talk about privacy of reads, right? So here's the challenge, right? Imagine that you're using a bunch of Ethereum applications. A lot of them are using zk snarks. It's private. It's super amazing. But you also need to read the chain. Every application requires you to check things like, what is your balance? What are recent transactions that I've received? It requires you to check a lot of things. And when you generally, because full nodes are so difficult to run, people do these reads by trusting an RPC server. And when you trust an RPC server, then the RPC server knows everything about which addresses you're accessing, what your IP address is, what sets of addresses you accessed from the same IP, and so it can learn the links between different accounts. Like, it can learn everything. So we actually have quite a lot of weaknesses here, right? And I think this is a problem that we've been historically neglecting. And like, we have things like Helios, for example, right? And Helios is a light client. It's a wrapper that can wrap around an RPC, and it can prove that the RPC is not lying about like the things that it's telling you about Ethereum. Now, this type of security is important, right? Because if you're making a trade on Uniswap, like say you're buying ETH for USDC, and you make a trade, and right now the price of ETH is 4,500. But imagine if you're buying 1 ETH, but then your RPC provider lies to you, and it tells you that the price of ETH is 5,500. And then you don't think, and you go and you click buy, and then you make a transaction, and then that transaction has a minimum price of 5,500, and then you could imagine that RPC server then grabs that transaction, it sandwiches it, so it attaches its own transaction right behind, and so you buy ETH for $5,500 instead of 4,500, and then the extra $1,000 gets immediately snapped up by the attacker that hacks your RPC. So this is bad, right? So what Helios is doing is important. But Helios so far has not even been trying to tackle this other problem, which is how do we protect your RPC from learning every single thing about your usage of the blockchain? So there's actually some interesting technologies there that we can talk about. So also, we can talk about not leaking to anyone other than the RPC provider, right? Like, it's one thing to have an application where the application talks to an RPC and you can choose who the RPC is. It's much, much worse when we have mainstream applications that are hard coding a bunch of their own servers to talk to, and then you as a user basically don't have a choice. So also, we can talk about hiding the contents of the read. We can also talk about hiding the timing of the read. So some technologies here that can help. So TEE plus ORAM, this is like a very short-term but very practical thing. Basically use trusted hardware together with this cryptographic primitive for encrypting the locations of memory. And what this lets you do is this lets you send a request to a server that basically says, I want information about this address, and the server responds to the request, and it does this without learning like what address it just gave you a response for. So this is powerful, and if you trust the hardware, then this basically solves the privacy of contents of the read problem. But trusted hardware, of course, a lot of challenges, and if we don't want to trust the hardware, then we can go to the next level, and then there is a cryptographic technology called private information retrieval that does the same thing with a much more unconditional level of security. Then you can also do like padding, and you can do dummy requests. So you could have your wallet can just automatically make a batch all the requests and make a request every, like, say 200 milliseconds. This is like the same sort of stuff that Tor does. And then like basically your RPC provider then knows nothing except, are you online right now? Are you offline right now? And that is basically all that they learn. So this is pretty powerful, right? And like this really plugs a lot of the holes that we have in terms of user privacy. One different approach that we can take is what we call partial state nodes. So a bit earlier, I was talking about how it's going to become easier and easier over time to run an Ethereum node. Now, why do you necessarily care about running an Ethereum node if you can just run a light client? Like, why do you actually care about holding all of the state yourself? And the answer is, well, you want to be able to read it, and you want to be able to read it very quickly and efficiently without actually having to without having to leak to an outside server what you're reading, right? And so this whole TE, ORAM, PIR, and like padding type of approach is one way of doing this, but it has weaknesses, it has more trust assumptions, it's more expensive, and so it would be nice to also pursue this other approach where you're basically just downloading all of the data locally. So if we do this, then basically, yeah, it actually becomes viable for you as a node, for you as a user to just download and store first the entire Ethereum state, or potentially you can go to partial state nodes which store not the full Ethereum state, but maybe a large fraction of it, and then you will be able to read all of the data that you need to read without even having to make any kind of request to the outside. So a lot of ideas here for improving privacy and reads as well, right? So this is the type of like comprehensive approach that we have to improving privacy on Ethereum. And there's a lot of other privacy projects that matter. So there's also L2s, Aztec and Intmax, I think, are both very impressive. There is a lot of like projects trying to make more privacy-friendly applications, a lot of important things. Now, another big focus is faster slots and finality, right? Basically, can we decrease the slot time in Ethereum, make the user experience even faster, and can we make transactions finalize even faster? So the main challenge here is, how do we do this safely? How do we do this without breaking Ethereum's decentralization, right? If we just suddenly reduce Ethereum's slot time to 2 seconds or even 1 second, maybe the Ethereum network will break, maybe it won't break, right? But even if it does not break, the problem is that once you push the slot time down that far, you create a huge advantage to whichever validators are located in the same place as all the other validators, right? And when you create that large an advantage, then that just creates this like very powerful black hole pressure, and it causes the network to all concentrate in one place at the same time. We do not want this. We want to make sure that it's economically viable for you to participate and be part of the Ethereum network from anywhere. So this takes a lot of research. It takes network optimizations, erasure coding. It takes three-slot finality, new consensus protocol ideas, new fast finality ideas. So a lot of hard technical work, but people are generally confident that we can decrease the slot time quite a bit, and we can basically make it so that if you send a transaction, you will on average maybe only have to wait 2 seconds before that transaction gets included into a block. One other big medium-term focus is also stronger guarantees for transactions, right? So basically, if you send a transaction, and especially if you send a more complicated type of transaction, like using a privacy protocol, like using a smart wallet, these are things that you should be able to do, and you should be able to reliably expect them to get included on Ethereum without needing to depend on trusted intermediaries, right? Today, a lot of people are really taking shortcuts on supporting smart wallets, and the shortcut basically is to make the whole thing depend on a trusted intermediary that packages your transactions. This is not acceptable, right? We want it to be possible to send transactions directly and get transactions included onto Ethereum directly. And this requires in-protocol account abstraction, so things like EIP 7701, and also Fossil, which is a proposal that basically means that you have about 16 different actors in parallel that are able to schedule transactions for inclusion in the next slot. And what this means is that even if block building gets very centralized, there will still be a strong guarantee that your transaction will get included on chain. Centralized block builders will not have the ability to just say, I don't like this set of transactions, and so I'm going to delay them for a very long time. So this is important, right? And these are things that are also actively being worked on. Probably will happen later than some of the short-term scaling stuff, but still important. Longer term focus, lean Ethereum, right? So this is the kind of subset of Ethereum research that's recently been run by Justin Drake. And lean Ethereum is Ethereum's long-term future, right? Basically, the idea is, we had Ethereum 1.0, the merge, you can call it Ethereum 2.0. I think lean Ethereum will be Ethereum 3.0. And what this means is we need to really make sure that every single piece of the Ethereum protocol is something that is simple, secure, optimal, efficient, that is good enough that we are comfortable with that piece sticking there for Ethereum's very long term. Right, so we basically want to look at every single major primitive that we use in Ethereum, including hashes, including signatures, including zero-knowledge proofs, including consensus protocols, including the virtual machine, including everything, and really figure out what is the ideal, secure, simple, optimal version of that thing, and incorporate, and then create a roadmap to actually bring that into the Ethereum protocol. So also, a key goal of lean Ethereum is quantum resistance. So a lot of forecasters believe that there is a 50% chance that we will have quantum computers that break cryptography before 2040, and even a 20% chance that that'll happen around 2030. And so what this roadmap will do is within a few years, it will give us quantum resistance at every single layer of Ethereum. Then also formal verification, right? So using machine verifiable proofs to verify that everything is implemented correctly, that everything satisfies the properties that we expect it to satisfy, to make sure that everything actually is secure, right? So really pushing Ethereum toward like actually being this like really ideal, clean, like beautiful base layer that actually makes sense to run the base of global finance for the next century. So what does all of this mean for users, right? I think the first important thing is scalability and usability will steadily increase over the next few years. So who here has sent a transaction in the last 6 months? Okay, good. Who here has not sent a transaction in the last 6 months? Okay, no hands raised, that's good. So who here feels like gas prices have been too high for the last 6 months? Okay. Okay, no, it's good. I mean, we need to be more ambitious, right? But relative to what they've been historically, the gas prices have been very low, right? Like today, even a privacy-preserving transfer, which takes 500,000 gas, only takes about $1 to $2 in transaction fees. This is like insane. Like I remember back in 2019, 2020, like a privacy-preserving transfer took $45 in fees. Actually, the highest I ever paid, at one point I paid an $800 transaction fee for making a private transfer. So compared to those days, fees have gone way down. Now, part of the reason why fees have gone way down is, of course, we have layer 2s, we have more places to do execution, and another part of the reason is that the L1 block space has also increased somewhat. Now, what we want is to make sure that L1 scales enough that fees stay low and ideally get even lower, even as we potentially get another crypto bubble and we get another big burst of user interest and activity. So this is the goal of scalability, right? To keep fees low, to push fees even lower. Also, improving usability. So reducing the amount of time you have to wait, reducing the number of clicks you have to make to do important things, improving user-level security, giving people more options for being confident that they will not lose their funds. Also, it will become possible to build L2s that have very strong scaling and UX properties, and that integrate deeply into and that benefit from Ethereum L1, right? I think the technology to launch your own L2 will continue to get easier and easier, and the technology for existing L2s will continue to get better and better. And what I think we'll see is L2s that really optimize around being very interoperable with this bigger Ethereum ecosystem and with each other. Also, trust assumptions will steadily decrease. It will be possible to do more and more things for more and more people in a way that is trust minimized, in a way that does not depend on like 5 different servers for the safety of your assets and like 15 different servers for the safety of your data. So there's a lot of challenges here, right? So things like the Bybit hack, they show that it's not just safety of smart contracts that matters, it's also safety of the front end, of the user layer. And this is something that we can improve. We can switch to front ends being on IPFS, and we can switch to a world where something like that is a default for applications. Also, I think we will continue to prioritize trustworthiness and security of the Ethereum L1. People and institutions value the Ethereum L1 because it is the chain that does not go down. And this is something that I think is continued to be important and that we'll continue to build on. And also, Ethereum will, I think, stabilize more and more over time, right? And I think it will become more and more clear over time what Ethereum's final form actually looks like. And there will be features that continue to change. And I think there will also be parts of the Ethereum protocol that become more and more stable pretty quickly, right? And so we will actually get to a chain that has a lot of scalability, that is very usable, that is an excellent base layer for building L2s and applications on top of, that is accessible for each and every one of you to run a node and to participate in directly, and that will be something that is secure enough to run trillion-dollar financial ecosystems and very powerful non-financial applications in all kinds of areas. And so I think myself and all the research and development teams are excited to making these things happen. Thank you.
Thank you very much. ありがとうございました。